Okay, so members, welcome. Today we are going to see some exceptional cases which we need to treat with a lot of care when it comes to these lines. Now, the examples we have express the following into vector form. You know that the vector form is given in the form of r equal to a plus lambda u. We say we can directly convert from the Cartesian, all these are Cartesian equations, to the vector form. So from here, we start always our r is equal to, we say, this one is not having anything without, so whenever it has no denominator, it means that anything without the denominator is the denominator 1. So this one is over 1. We start by putting that. So now we pick the point. The point we say we change the signs of these ones up. So this will be now 1, 2, then I change this one and get negative to opposite sides. Then plus lambda. Then we say to get a power we just pick out these ones. So this will be 3, 1, negative 2. Now, when we come to this one, be careful. You start this one and this one, they are somehow different. You see this one we are from x now to z, and then they are putting comma, y is this. Now, whenever I say they are giving you a specific value of y in the Cartesian equation, it means that the coordinate of the parallel vector of y was 0. Because we can't say that y minus 4 over 0. Because in mathematics, you know what this is. This one is going to give you a definite and infinite value. So to avoid this mistake, when it's always 0, they just give you the value of that y. So from here it means that the parallel coordinate of the parallel vector to y was 0. So to write now the vector form of this, I pick a point. This one is negative 1. You see that for y now they are telling me that y is 4. Now I come for z, which is negative 2. Now when I reach the parallel, this one is negative 2. Now for y, because it's in the order x, y. Now for y, I put there a 0. Now for z, it is a 4. Be careful there. To emphasize it, I'm going to come to number 3. From here, so that my r is going to be a point, so that this one has no any coordinate, so it's just for 0. This one is 4, multiply. Now the value represented is negative 3. When I come now to the parallel vector, this one is 5. For y is negative 3. But because you said they are giving me z is negative 3, it means that its coordinate on the parallel vector, it was 0. So whenever they give you, they define for you the value of either x or y or z, it means that the coordinate for the parallel vector of z was 0, like that. So put this in mind whenever you have a 0 coordinate in the parallel vector, it means that they are going to give you exact value of that y. And like here, you see that here we just pick it out. Be careful. Now, when you come to this thing, you know that always our Cartesian, all x, y, and z should be positive. You have to first check. When you check in this now, you see that your x is negative, your y is positive, so y has no problem, but your z is negative. What you do, you first make them positive. So first of all, to start with, you see that this one is over 1. So to make this positive, it means that I'm going to multiply a negative 1 up and negative 1 down. This one is okay because it's positive. And it should be always coefficient 1. This x, y, and z, they should be having coefficient 1. So see, this one is negative. So if it's negative, you get, if it's 1, you just multiply by negative 1 up and down. So from here, I'm going to multiply by negative 1 up and times negative 1 down. Start. It will be almost not there. Then when I come also here, the same thing, up, I multiply by a negative, also down by -1. Such that I make this x positive. We don't mind about these constants. This our x should be positive. So this negative times this, I have now x. This -3 over -1 equaling to y is okay. Equaling to this negative times z. Negative z you get positive z. Then this time this you get -1 over negative and negative you get a positive 2. So from there, members, you see that I can easily now pick out I can convert this to the Cartesian, to the vector form by picking change the sign of this. So 3, -1, 1, then plus lambda. Here we have -1, 3, 2. So this one we just pick them where they are. So always we first take the signs of x, y, and z. When I come to this, this one is even harder. This one is this coefficient of y and the x, x, y, and z, they should be always 1. So see this one is 1, so this one is 1 and positive. It should be positive 1 strictly. So this one is okay. This one is the coefficient of y is 2. So there you get annoying. Even here, the coefficient of z is -3. So how do we handle that one? Now how you handle that one? You just multiply through by the reciprocal of the coefficient on that value. So here, you start the coefficient is 2 with its side. So its reciprocal is going to be, so I'm going to multiply by a half. When I come to this one, start its coefficient is -3. Now the reciprocal of -3 will be -1/3. So on this, I'm going to multiply through by -1/3. We base on the coefficient of z. Here we base on the coefficient of y. This is 2, its reciprocal will be a half. This is negative with its sign -3, its reciprocal will be -1/3. So we multiply it here and here. So now, this one is okay. Will be equaling 2. Now we start with 2y plus 4 over 6. So you multiply up by the reciprocal of the coefficient of y, which is a half, over, you also multiply this side down by a half, so that you don't change anything. Equaling 2, now 4 minus 3z over 2. So this side you multiply with the reciprocal of the coefficient of z, which is -3, will be -1/3, and you multiply it up and down, so that you don't change anything. Let us now, I have this as x minus 1 over 2 equaling to the multiply a half here, we have y plus, when I multiply a half here, I have 2. When I multiply this and this by a half, we have 3. When I multiply negative, this will be now positive, then this will cancel this, and we have now z. Now, a negative and a positive, I have -4, then over 3, over this and this will give me -2 over 3. So from there you can take convert it to vector form by saying now R will be so members, that's it. Let's start. Now here in example 2, they are asking us to express the following into Cartesian form. Now to express this in Cartesian form is very easy. You know that this one is always in x, y, z, so it's going to be x. You change the sign of this one, you take this side, so -1 over the corresponding coordinate, the exponent of the vector. Then this one will be y minus this over 1, the corresponding coordinate of y in the vector. Then this will be still z minus 1 over -2. As simple as that. We are converting from a vector to the Cartesian. Now, when you come to this one, now you take note. Why? because we see there is a 0 in the parallel vector of this line. So this one now will be, you see this one has no problem. So it's going to be now x. If we turn this, we get now plus over 4 equaling 2. Now we see that y, it's 0. So I first read that one. Now we count this one, it's not that into the z. So it's going to be now z minus 2 over 7. Now for y, you just take the coordinate there. So my y, by the way, not to confuse people, let me make this one 4. So that there, my y will be 4. Why? Because I can't say y minus 4 divided by 0 in mathematics. That one is a very big mistake. So when I come to this, I have now x minus 4 over 0, which can't be possible. So that one I can't write it. So therefore, I clean out that one. Meaning, I go to the next, which is now y. So you see y plus this over negative 2 equaling to z plus 3 over 1. Now, because this is 0, I'll just take the value of x as x equaling 4. So this is where we started from here. So remember, as I was showing the best, I wanted to clear those exceptional cases. Don't forget to subscribe to the channel. I sign out.